We present our work from Google on efficient heterogeneous video segmentation on the edge, which enables many computer vision tasks. However, high-quality real-time video segmentation on web browsers and smartphones poses many challenges. Here are some of our challenges. First, we need to handle the trade-off amongst input resolution, model accuracy, inference, latency, and power consumption. Another challenge is the heterogeneous compute architecture, where all of the CPU, GPU, and often the NPU come into play. NPU being the neural processing unit, specifically designed for model inference. We address these challenges in the following slides. To find the best model architecture, we search over the following dimensions. For decoder block, we found that MLP decoder delivers quality close to channel attention and speed close to bilinear upsampling. For convolution block, we found that grouped convolution improves NPU utilization, hence reducing latency. For input resolution, we choose 512 by 512 as quality improvement diminishes beyond this resolution. To run HD segmentation in a browser, we benchmarked off-the-shelf WebGL inference engines, which only ran at a third of native OpenGL speed. Our WebGL implementation uses a GPU feature called multi-render targets, which allows rendering images and tensor to multiple textures at once, hence reducing memory I/O latency by 4x. With this and other techniques described in the paper, our implementation can achieve over 90% of the native OpenGL speed and deliver frame rate at over 30 FPS. While the model inference can run much faster on the NPU of a mobile device, a naive replacement of the GPU inference component with its NPU counterpart can introduce major system-wide inefficiencies such as interprocess data copies and synchronization. We eliminate these latencies by using the shared hardware buffer available on modern mobile SoCs and the Android synchronization APIs, which allows direct communication between the GPU and the NPU. Hence, the optimized mixed GPU-NPU pipeline is faster and consumes less power than a GPU-only pipeline. We demonstrate our approach to achieve higher accuracy and efficiency. We expect our experience to be applicable to many real-time AR/VR applications. From all of us at Google, thank you for watching.